Hello everybody. I class started today for me, and everything's online this semester. So I took a snippet of a lab that I'm gonna have to do at the end of the semester, which I won't wait till the end of the semester to get it done. Um, I thought it would be kind of cool to go over a kind of a flyby view of the particular uh, topology that was listed in here and some of the network requirements. And as I was reading through, most of this stuff is pretty straightforward. If you, I'll throw together a quick spanning tree and VTP video, and so that kind of explains that. Because if you don't know what spanning tree is and you don't know what VTP is and how they work together, then I'm actually, I didn't really see my fingers as I say that. It'll be difficult for you to understand the first two and what a VTP server and a VTP client are. And then going based on just what I'm reading here, between R1 and R2 is frame relay. Well, R1 and R2, I'm not sure if she means that this is going to be back-to-back frame relay, where it's going to be interface delc as the command, and interface delc here, and it just points to this one like a default route would. I'm gonna have to read into it just a bit more before I get into it, but there was one thing down here. It says source IP address spoofing right here. Actually, I need to make that a bit bigger. This one right here. That threw me. I was like, what is that? I've never heard it referred to that way, but after doing just a little bit of investigation, basically it's the same thing as a denial of service, which basically means in denial of service attacks, if you understand how the TCP/IP protocol stack works, when you have a uh, when you're trying to connect from a on a switch, or when you're trying to make a TCP connection, there's um, a sequence that's gotta happen, and I actually want to go to Cisco's website and reference this. Um, my internet is going really slow. Might have to restart my computer. Okay, here it goes. Um, the TCP/IP stack does something like this. Um, yeah, this computer right here will send a TCP synchronization packet to, let's say this is the server that it's trying to go to. This server receives a SYN, and then now I'm writing with a mouse, so it's not going to be the prettiest. And then what this guy sends back this way, a SYN-ACK. So it's going to be a SYN-ACK, which is a synchronization and an acknowledgement. It says, okay, I accept that connection, and then I'm going to respond. So it comes back down here, and then this guy receives the SYN-ACK down this way. Well, that's as far as it goes in a spoofing attack, because the third would be an ACT, it would be another acknowledgement, the SYN-ACK, and it would go from the PC to the TFTP server. And this guy would get an acknowledgement. And then there'd be, and the process just keeps recycling itself over and over again. And then, but the synchronization is a number. So you start up with SYN1, and then once the ACK goes through, then it says, okay, then this is where windowing comes into play. And so then you synchronize up and you say, I'm going to send, okay, be 8. So the first 7 go through, then 8 picks up, and then it synchronizes, so on and so forth. What ends up happening is in a TCP spoofing attack is the first two get sent, the SYN and the SYN-ACK. The second ACK, this never goes through. This is what they call a open, or a TCP open, and because it's usually a closed session between two devices, when it's not completed with a three-way handshake, it's this way goes here, this way comes back, and this way goes up, and then it just keeps doing itself over and over again. So if you don't get the third, or the ACK back to the server to acknowledge that there's this open session, which basically ends up being a tunnel. So it's like point to point at that point, even though it's going through the network. There's a port, a socket open up in the fire on all of the the routers from the inside to the outside. Um, so this would be the inside, this would be the outside. If you're using NAT, it just basically NATs it for the public or private IP to the public IP to here. So that's the basic concept of how. Oopsie. Um, I didn't expect that to happen. Um, but anyway, things do happen. So give me a second, I'll fix that. As I was saying, I went ahead and I fixed it real quick for you. The source IP address spoofing should be prevented on all links that do not connect to other routers. That's pretty straightforward. It just means that you want to make sure that you're not allowing spoofing attacks, which is an ACL type of situation. I'm guessing that's what she's wanting you to do without reading. I haven't read through the. There's actually a script that she wants you to put in the router so that it gets you up and running faster, so you don't have to sit there and type on each router and switch. But it says S2 is the spanning tree root and VLAN for VLAN 11, and S3 is the spanning tree root for VLAN 30. Assuming, now that I haven't talked to her, emailed her, and asked her anything, assuming that she's going to go over all this stuff, it's going to be pretty straightforward. Now, spanning tree is switch to switch. So switch to switch communication. What does that do? Well, these guys right here, this right here, and this right here, these are what they call crossover cables. They are like device communication. So computer to computer, switch to switch, router to router, router to PC, because at this point it's NIC to NIC. You're going to have crossover communication, which means the pins are flipped. I forget which pins exactly there are, or which wires are flipped over inside the jack, but they're flipped over so that the send goes on the receive and the receive goes to the send. So that's basically what they call crossover. But what spanning tree does is, by default, it blocks ports. What does that mean? It kills this connection right here, because what will end up happening is, what this guy does is it sends out information this way. This guy sends information this way. So what ends up happening is it loops. Just starts looping and looping and looping and looping. The processor on this thing goes to 100. This one goes to 100, and the network crawl comes to a crawl. So what we do. Maybe I should give you just a bit of background on me. That probably would help you. My background is mainly Cisco. I've studied the CCNA pretty much through its entirety. I'm going for the certification this semester, and then I've already been through the CCNA program, or not the program itself, but all the topics and the training through actually 3 different vendors. I've gone through CBT Nuggets, Internet Network Expert, and Train Signal. I've everything that I've gotten every bit of information for the CCNA I can, and I've compiled it, and I've taken notes, and I've studied and configured, and I've gotten pretty good at it. It's actually, I work as a network support engineer for a company up in Brookfield, so my skills have gotten me good enough to where I can support a large enterprise network. My skill, I'm going through the CCNP, the Network Professional. This class is for the CCNA, the Network Associate. I've been through the CCNP track already, so advanced routing and frame relay, BGP, advanced switching, where you're dealing with layer 2 and layer 3 switching, routing your VLAN, stuff like that. That's all stuff that I'm really familiar with and I deal with every day. I'm actually studying for the CCIE written exam right now, which takes the entire stretch of routing and switching, and it brings it into your test on anything that can possibly be configured in the operating system on a Cisco router or switch that falls into the routing and switching categories. So you're not going to be doing in-depth VPNs or setting stuff like that, or you're not going to be doing anything crazy on security, because of the fact that they have a security course for VPNs and stuff like that. So they have the CCIE security for that. You're not going to be doing anything voice, because they have the CCIE voice for that. So it's going to be anything routing and switching. And then, I mean, there's going to be some security. some quality of service for voice and video and stuff like that that you're obviously gonna have to know about. But that'll give you kind of an idea of where I'm at. You can go to Cisco's website under the training and events and click on the CCIE. If you don't have a login already, you can register with them for free and look at the exam blueprints. It's pretty expansive, so that kind of gives you an idea where I'm at. So what I'm doing is I'm basically for this is I'm taking a look at the topology, which is actually it's kind of in depth. I'll give it some credit. Whoever put this together, took some time to make sure that the actual cabling and the physical nature of the network is actually pretty straightforward. You have your point-to-point connections right here, which point-to-point meaning it's two devices, which hence is the /30. So you got that, and then you've got your subnetworks. So you've got network here, network here, network here. Now, what I do when I'm usually networking, which is actually what I've noticed right here, the VLAN 11 on switch 2, which is right here, that's the subnet, switch 3, subnet VLAN 30. Typically when you're setting your VLANs up, you want to keep your VLAN numbers equal to the subnet IP address. So VLAN 11 would be the 192.168.11.0. VLAN 30 would be the 30.0 network /24. /24 means you have 254 usable hosts on that network. Same thing with this guy. This means you have 2. And if anybody cares to know, this will be on my my YouTube channel where I explain subnetting quite in depth, and I break it down on how subnetting works and how you would address. So what I'm basically going to cover real quick in here is explain how spanning tree would affect it, VTP. Theoretically, spanning tree and VTP need a video each a piece because of how in depth it can get and how the ports lay out and how the switches determine which switches get what. For the sake of argument, I'm going to basically cut that down in half, and I'll kind of give you a flyby as to why it'll do this. And without a command line in front of me going through how the commands work and showing you specifics, this is more of a theory type side so that you can understand what spanning tree is and how it works. Same thing with VTP, because in all honesty and in the real world, you're not going to sit there and get really particular with your VLANs, because I work in a very large enterprise network, and the network itself, the company I work for, has a multiple thousand node network, meaning lots of routers, lots and lots of switches, lots and lots of firewalls, intrusion prevention, intrusion detection. It's a large financial institution, so a lot of what I do is making sure that runs. Now I'm not in charge of the whole network. I only monitor a small section of it, but my section, I dive into everything. So a lot of what I deal with every day gives me the ability to look at this and be like, okay, I know exactly what's going on here almost out of the gate. And so I'll quit babbling about my job and what I do, because that's not why you guys are here. Basically, this is what they consider a lab. So, like, this would be the CCNA version of the CCIE lab, because you have switching, you have routing, you have some services you have to put in, like DHCP, stuff like that. So, a lot of what you're going to see in this class is going to be the CCNA equivalent to the CCIE lab at the very end. So, this will give you good practice. Actually what I'll do is, I don't know if I have the file pulled up, or if I could even pull it out. But let me open up Packet Tracer and see if, I don't know if it's going to open up on that screen or not. As I was saying, I've got little kids here at home, so a lot of what I do is deal with kids. Anyway, I found an old file of mine that I was working on that I'll bring over. This is one of the networks that I put together. It's not much different than the one you see back here, but this is what I was actually, if you look, it says, CCNA. When I was going through my CCNA training, this is what this is the topology that I was able to build, and I have a fully fully working CCNA or frame relay network up here, and then I was actually testing some spanning tree to see exactly how many hops it can go before it starts goofing up, and trying to get some. I never actually finished the topology. I got everything up to here works. This extra stuff down here, it doesn't work. All the stuff over here does. I used to be able to. Now I haven't. I don't know if the file got corrupted or anything, but I used to be able to ping from here to there, back and forth. So no, I do not want to save. But basically, what it comes down to is what is spanning tree? Well, spanning tree is a very simple concept. If you have two crossover cables connected to two different switches, or spanning tree blocks one of them. Well, how do you know which one to block? Well, by default, spanning tree goes for lower is better. What do I mean by that? Well, there's a couple of reasons. There is a BPDU. BPDU is a Bridge Protocol Datagram Unit. What that does is that's the switch's way of saying, hey, what's the network look like? And so it sends a BPDU out this way. This guy gets it on this port and then sends it back out. And then this guy gets it on this port. Well, by that happening, and it keeps going around and around and around and around like so, that creates a loop. And like I said earlier, that processor utilization goes through the roof. So what spanning tree does is it blocks one of the ports. And there's spanning tree can be kind of a pain in the butt. It can make or break your network if you're not careful. That's where VTP comes in. But I'll finish up VLANs spanning tree real quick. There's a BPDU that is sent out, and each switch by default starts off with a priority plus the MAC address. It determines the root bridge. Well, what does all that mean? Well, there's a root bridge, and then there's non-root bridges. The root bridge is going to be the oldest switch MAC address, meaning the MAC address of the switch, not the ports on the switch, and not the MAC address of the devices, like PC3 connects to switch 3. It's going to be the MAC address of the switch plus the priority. Priority is 32,768. You will see that number a lot when you're both subnetting the larger networks, like 32,768 hosts on a slash, is that a slash 18 network? So 32,768 plus the MAC address. So the BPDUs are sent to each switch. In this case, it's only 2, and the MAC address. So whoever has the lower MAC, so MAC address is looked at. Whoever has the lowest MAC and the lowest priority wins. So by default, this is the default priority. Default or the lowest MAC address wins. So if you have a MAC address of 1111 and 32,768, and you have a MAC address of 1110 and a priority of 32,768, this MAC wins because this MAC is lower than this MAC. So it only takes one hexadecimal value to change that. Well, you can't change the MAC address theoretically. You actually can, but I'm not going to get into that. So how do you change the MAC address, or how do you make this guy to be the root for both of them? Even though that's not what's going to happen. This will be a root for the VLAN 11. This guy will be the root for VLAN 30. Well, we're not going to worry about that right now. We're just going to explain what the spanning tree and how it grabs its information. Well, what you can do is you can change the priority per VLAN. So you can go in under VLAN configuration mode, or go into global config and type in spanning tree. So you type in span tree. That's horrible typing. So it's tree, and then you type in VLAN and then the number, the VLAN. Now you have to already have this VLAN created. So you create the VLAN, so you go into global config, you type in VLAN 11, and then it's created. And then all you have to do from there goes into the VLAN configuration mode. Don't worry about it. Type in VLAN 30 if that's what you want both VLANs to be able to go on both switches. So you type that in. I know this is a little vague and you're like, well, how do I do that? This is conceptual. This is how it works. I will shoot another video where I go through the actual setup of spanning tree, the actual setup of VTP. So don't worry about it. There will be a demonstration probably another day or two now that I've seen what we're going to have to deal with. So spanning tree VLAN and then the number, and then you type in root, and then next for that VLAN creates the root. Well, there's a bit more to it than that. Or you can type in primary, and then or you can do the other command, if I remember correctly, is spanning tree VLAN number, and then it's priority, and you can specify the priority, and there are increments of 40, 96, and so that gives you 0 through 6, 5, and change, like 5, 3, 5, and I believe it's there's 15 different values you can give, or 15 different priorities. So with that being said, well, can't go that far back. So what ends up happening now is you can set the priority by the priority command, or you can make the particular VLAN the root bridge by saying root primary, root secondary, in case there's a failover. But what ends up happening is the root bridge, let's say this guy's the root bridge, the ports going this way are called designated ports. Okay, designated ports always point away from the root bridge. So this is the root bridge right here. Switch 3 is a root bridge, and then all the ports being forwarded towards switch 2. So switch any ports going towards switch 2 or facing switch 2 are designated ports. The ports facing the root bridge that aren't blocked are called root ports, meaning switch 2 facing switch 3, those ports are known as root ports. Anything facing, it doesn't matter if it's one switch or if it's a 2-switch spanning tree network like this one is, and this guy's your root bridge, and these guys are designated ports this way, and these guys, and these guys are root ports designated this way. It doesn't matter how many switches you have. I think it's up to 6 or 7 hops you can have in a spanning tree domain before it won't know which ports to block, and it kind of like it's like RIP. It has so many routers it can go before it doesn't know what to do anymore. So that keeps going. So anything going away from the root bridge is designated, and anything facing towards the root bridge is a root port. Now, how does it determine which one to block? Well, if this guy right here is the root bridge, and this guy is the non-root bridge, the lowest port ID wins. So this guy was the lowest port ID, so this guy would get blocked. So this guy gets blocked, and then if you were to look at it in the show VLAN, show spanning tree, it would show you on which VLANs are designated ports, which ones are blocked. Now, with that being said, there is a thing called spanning tree protocol. There is rapid spanning tree, which is the next generation. Then there's PVST, which is per VLAN spanning tree. Then there's this, and then you add a plus onto it. You can have per VLAN spanning tree, which is actually what you want you to do. Per VLAN spanning tree means you take and you choose the root bridge on a per VLAN instance. Now, it's really hard for me to explain it and not go into detail because of the fact of what's going to be out there. Spanning tree has it's got an Achilles heel, meaning it takes forever for a blocked port to go from blocking to forwarding, and it's like almost a minute. And in production networks today, that's too long. So actually what ends up happening is, assuming that the spanning tree topology has converged, it's got its blocking ports, designated ports, and root ports. It's in blocking mode, so we're going to put BLK.
and then it's blocking. And then let's say for instance this link right here gets cut. Okay, what ends up happening is fast Ethernet 0/4 gets transitioned out of blocking mode into what they call listening mode. I'll type in LIS. This takes 20 seconds. Okay, it takes 20 seconds for it to transition. Then there's learning, LRN. This is 15 seconds. Or I'm sorry, take that back. I'm wrong. This is 15 seconds. This is 20. Learn is 15. So 15 and 15 is 30, plus 20 is 50. So almost a minute for it to transition into forwarding, FWD. Forwarding means it's a root port facing the root bridge. Okay, so these are the four different stages. Technically, this one, and this one are valid. If you are going to, if you're an exam person, make sure you learn them in this order and know the times. So 20, 35, and 50. Now, assuming that everything is running, what do you call it? Everything's running legacy spanning tree. Spanning tree has been around for like 30 years since the advent of the switch. So what ends up happening is network administrators and engineers and stuff like architects, they need to speed it up because nowadays you have voice over IP and other types of services running across your network where if it has to wait 50 seconds for the network to converge, that's just not going to happen. You have SQL Server stuff and you have internet traffic and all types of stuff. I won't even get into it. So they came out with Rapid Spanning Tree. RSTP. Rapid Spanning Tree, it is a significantly faster way of converging your spanning tree domain. Spanning tree at this point is like I said, it's legacy. You've got to go through your different modes of how fast things go. Spanning tree, it fails over instantaneously. You might see 1 or 2 second delay in connectivity, but it's just because the failover is happening. So if fast Ethernet 4 is blocked, and then this guy gets killed, and this guy's got to go into designated forwarding mode, then rapid spanning tree has got to kick in. The only caveat with running rapid spanning tree versus regular spanning tree is when you're running regular spanning tree on your switch environment, in order for rapid spanning tree to come into play, all switches have to be running it, and you have to give it time for it to replicate, which is where VTP comes in. But so once you get rapid spanning tree working, and you go in and you configure rapid spanning tree, your spanning tree mode rapid, go in that way. It'll pull it up, and then all the switches will run it. Give it some time, maybe a few seconds for it to converge and do its thing, because then, it still has the same concept with blocking ports and stuff like that regular spanning tree does, except for it's just faster when links get cut or go down. So the spanning tree concept is the same from spanning tree to rapid spanning tree to per Vlan spanning tree. The concept is the same. It blocks ports that it needs to block. Well, in the course of doing that, some things had to change. Well, because you might have an environment. Let me open a packet tracer once and pull out a topology that I built a little while ago. This topology's been I've had this one for a long time, and this one just I went to town one night. I just started throwing stuff out on a packet tracer. This thing is bonsai big, and let me fast forward time here so everything gets doing its thing. Now, I was actually trying to make this a lot bigger than I ever thought I'd be able to handle. I got confused somewhere in here, but anyway, as you can see, if you notice how, let me do options, preferences, and show. This is going to gum it all up, but that's okay. So what I'm going to do is I'm going to zoom in a bit for you and kind of show you what I mean by this. You notice how that's a bad example, but um, fast Ethernet 0/1 comes to here, and fast Ethernet 0/5. Notice how it's orange? Well, that's how spanning tree works. It blocks that port. So, same thing with here. Because of the fact that this guy has a connection to this switch, this is the root bridge in this domain. Okay, I remember that from configuring it. This guy is a root bridge. This guy is this is a root port facing the root bridge. These are designated ports right here. So this guy right here, root port, this guy is in blocking mode. Same thing with this guy. Same thing with this guy. So technically, if this switch was to fail, okay, these guys right here would be screwed. Why is that? Well, because if this switch fails, or at least one of these links fail, let's say this whole switch died, okay, this guy, whoever has the next lowest priority and MAC address wins the root bridge election. So what ends up happening at that point is either this guy or this guy will win the spanning tree root bridge election. So without getting into the switch itself, that'll determine what gets which switch gets it, the root bridge. So let's assume that this guy does. So what will end up happening is these green lights will stay green, and this light will go green. This light will stay orange, and these lights will they won't be there because this link is dead and they're not going to see it anymore. So as you can see, I actually had some VLANs configured, VLAN 10, VLAN 20, and this was, like I said, this was the beginning of my CCNA studies. I really wanted to play with some different configurations and really get an idea of it. In all honesty, when you're going through your studies without real world experience and some actual seeing stuff break and trying to figure out how to fix it, you're going to struggle. I mean, I work in a very large production environment. If I didn't have real world experience, I wouldn't be able to tell you guys this stuff right now. So, like I said, when you get Rapid Spanning Tree up and running, I wanted to bring that topology in so you could kind of get an idea of what I was talking about. So, now let's assume that this switch fails. Okay, this switch dies. This one takes over as the root bridge. Well, there's no other switches to deal with, so by default. So let me now per VLAN spanning tree is a little nicer. So this is actually going to work twofold for me. There's for every VLAN you create, so if you create VLAN 1 through 100, you actually have 100 VLANs in your network. I don't see how you could even come close to having that many VLANs, but so you do. For each VLAN you have, there will be a spanning tree instance per VLAN. So you'll have 100 different. If you typed in show spanning tree, you'd have 100 different instances. So 100 different VLAN topologies or spanning tree topologies for each VLAN you've created. So that's gonna be resource intensive on the switch. So what will end up happening is like I said, there's gonna be a MAC address and a port and a priority. Well, there's still gonna be an election process, and in this case, we're just gonna go with VLAN 11 and 30. So what ends up happening? Well, on per VLAN spanning tree, you can specify the root or the root bridge per VLAN. So you can load balance across these and utilize both links without spanning tree getting in the way. How does that work? I thought spanning tree blocked the lowest or the highest port on the non-root bridge. Well, that's true, it does. Not when you're dealing with per VLAN spanning tree. What ends up happening at that point is you're able to forward across the unused link. Is there going to be an issue with that? Well, theoretically, there could be, but I've seen this in in production environments a couple of times where I've consulted and was brought in as an outside engineer and looking at stuff. Why do I call myself an outside engineer? Well, I actually have to learn how to. Well, I've done it a couple times where you come in, you're looking at the situation, and an engineer works with intolerances, so you know what spanning tree can do, you know what VTP can do, you know what your routing protocols can do, you know how to route your VLANs, you know how to limit who can access the information on those VLANs through ACLs, access control lists, and so on and so forth. So being able to work within your tolerances will definitely help. So per VLAN spanning tree, I would recommend anybody that wants to know more about that, Internet Network Expert, INE.com. If you create if you register on their website, and actually I will, I'll go to their website real quick, and .ine. If you log in, and let me log in real quick. Alright, now that I'm in, oh, I didn't even know I had tokens. Sweet. Thanks, INE. So I will bring this over here, and actually it's going to start firing up. And this is Brian McGann. He's a triple CCIE routing and switching service provider and security, as you can see right there. This is the introduction.
Good morning, everybody, and welcome to the CCNA bootcamp. My name is Brian McGann, and I'm going to be the instructor for this class. A little bit about myself. I'm from Chicago, and I've been in networking for about 15 years now. And I originally started in Microsoft networking, doing like just desktop support and PC support, and then I got into like Windows Server type stuff. Went through the MCSE in NT4, which is quite a while now.
And my internet connection is starting to drag.
Probably 15 years. And then eventually that led me into CCNA and CCNP. So it definitely was.
A quick note on the CCNA and CCNP, when he got them was back in 2000, 2003. Back then they were just a straight multiple choice exam. So how long is Ethernet good for to not lose any packet loss or anything like that? 100 meters, stuff like that. So and actually if you come down here, he talks about spanning tree protocol. It's an hour-long video. He talks about selection path and rapid spanning tree. He talks about VLAN trunking and VTP, which there's a reason why you have VLAN trunking protocol, spanning tree, and STP path selection all in the same section. It is, in my opinion, extremely important for anybody that wants to be into networking to go through this. Now, I've been through all of his videos. They're 23 hours, which you figure you average a video a day. It takes you a month to go through here. He takes him. He goes through command line references, stuff like that. So, actually, I'll pull up VLAN and let that load up real quick. Now, this is free. Doesn't cost anybody a dime. This is on their website, streaming. You can, if you want to download it, it's $100 to buy the series. I don't see a reason to buy it when you can watch it free online. So
Okay, so again, in the last example we were looking at,
he has a similar type of topology where, unlike in ours, he's got a couple layer 3 switches, which when you get into routing your VLANs, you'll learn the term router on a stick, to where you have to take the switch port has a VLAN applied to it, which this computer is in VLAN 10, let's say, and I'm on port 24, and in order to get off of VLAN 10, it's got to get routed to VLAN, say, VLAN 15. So to get from VLAN 10 to VLAN 15, it's got to get routed. So you have to have an interface, a default gateway for your VLANs. So that's going to be, I think in this class, I think this is what's going to be the hardest part for people, is to understand how logical versus physical is going to work. So, but like I said, check this out. This is a great tool. I actually reference it for core concepts. Actually, to be honest, in all honesty, everything that you see in here is going to be a basis for you when you get to the CCNP and the CCIE. There's only a few things in here right now that you don't see you're going to have to deal with. You're still going to have to deal with security. I don't know if, see, he's got ACLs right here. That's security. There's going to be a couple of other things like you're not going to see QoS at the CCNA level. You're not going to see heavy security like iOS, IPS, and stuff like that. You're not going to see QoS. You're not going to see multicast. You're not going to see BGP. You're not going to see MPLS. So this will lay a very good foundation for you in order to get very strong with your CCNA skills. So if you can get all the way through here, this will give you a very, very, very good base for you to get your CCNA. Now he goes through everything and how everything works and the best way to go about doing things and stuff like that. So internetINE.com. Don't worry about all this other stuff. Just remember to go to the very top. Actually, let me back up just a couple. This is my log. Actually, I could log in and get a rack rental, but this is INE. Actually, let me do www.ine. There we go. If you click right up here, click on Members tab. Now I'm already logged in, so it's going to take me back here. It'll take you to this. Now they have a self-paced where you can walk through, and it'll the exam where you can, and this is, like I said, it goes over everything you're going to need to know. You can buy this course for $100 or just watch the video and register and watch the video. Now, this is what I'm studying right here. Self-paced and training bundles. I've already got the video course. I've written through the CCNP, been through the CCIE, written videos. I'm going through the Advanced Technologies course right now, and I'm going to grab the workbook. But what I'm going to do is I'm going to grab the workbooks, and $600. It walks you everything through you're going to need for your CCIE route and switch. Now this is me. I'm not pushing the CCIE on anybody, but I wanted to give you an idea of what I was dealing with. So, the point of that wasn't I don't get paid. I don't get any endorsements for INE. It's just that I know it's a really good training tool. I highly recommend it. So, PVST. That's how you're able to work with path selection and stuff like that. So, I don't want to confuse anybody and be like, well, you said you block a port. How does it go across? I will discuss that in a later video because right now it's, I think, too much off the top. But VTP, what is VTP? VTP is VLAN trunking protocol, and what does it do? Well, you're gonna have a server and a client, just like you would if you had a server and a client. Okay. In order to get information from the server to the client, there's got to be a solid stream of information going from here to here. Okay, and then vice versa. He puts in a query down here. This guy gives him a result. That's all servers and clients do. So, what do we do? Well, real simple. With the VTP server, on the server is where you configure your VLANs. So your VLAN 11, 30, and whatever else, you configure them on here. This will be your VTP server. what ends up happening is it uses VLANs and trunking. So these ports right here have to be trunking. You would go under the interface and you type in switch, but you'd go under and you'd say switch port. That's abbreviated. You'd have to actually type in SW and hit the tab key. It would auto finish it. Switch port, encapsulate or switch port trunk encap .1q. .1q is the open standard, so this would be what you would type in order for it to get up and running to become a switch to the encapsulation, so it knows what tags to put in the layer 2 header, and then you type in switch port mode trunk in order for this to become a trunk. In order for VTP to work, it has to have a trunk port for it to go across. Now, there might be the argument, well, if there already a spanning tree kicked in, it should be a trunk already. Well, by default, there's this thing called dynamic desirable. What dynamic desirable means is it will auto-negotiate its mode, access port or trunk port. An access port means a single device connects to it. Computer, router, printer, wireless access point, whatever else. You would connect those to a access port. Theoretically, a router would not be correct. We'll scratch that. Computers, printers, access points, that type of stuff. A trunk port connects everything else. Routers, switches. Trunk ports mean that you can route multiple VLANs across it. It doesn't have a stipulation that can only have a single VLAN attached to it, with the caveat of voice VLANs, but we're not going to go there right now. So basically what you end up getting is you configure this port and this port to be a trunk, and assuming that we have rapid spanning tree in place, we put PVST in place, per VLAN spanning tree plus, and what ends up happening is you configure your VLANs on the VTP server, and you configure this guy to be your VTP client. So this guy is VTP client, and what ends up happening at that point is the trunks replicate, or the server replicates information out of the client, and then the client populates the VTP database, just like it would be if you were to deal with any other type of server. Server sends information to the client, just like this guy sends this guy to the client. So it populates VTP down to the client. Then if you were to do a show VTP status, it would show which VLANs are in there for each change. Whether you're deleting or adding or modifying, there's a revision number. Revision starts at 5. I'm sorry, 0. Number of pre-configured VLANs is going to be 5. You're going to have VLAN 1 by default, because that's everything is in VLAN 1 by default. Then you're going to have 1000, what is it, VLAN 1001 through 4, right? 1, 2, 3, 4. I honestly don't remember. But there's going to be 5 VLANs. You're going to have some FIDI, fiber distributed ring, and then like your token ring and some stuff like that, some old school legacy stuff that isn't supported anymore, but they're active. So you're going to have 5 VLANs by default, which will be this guy will be over here. You'll have the number of VLANs. You'll see 5, and for each additional VLAN you create, it will increment 1. So this one will increment to 1. This one will go to 6, and so on and so forth. So you configure your VTP. In order for VTP to work appropriately, you need to configure you need to change the host name on the switch to something other than switch. You need to configure a domain name. So whatever the domain is. This will actually come into play when you're routing your VLANs. So your host name, the domain, and you have to set a password. So you get those 3 things put in place, you'll be good to go. Now, when you're configuring router on a stick. What router on a stick does, I know I'm kind of flying through this stuff because I want to cover it so you guys are at least familiar with it. What router on a stick does is you configure a trunk port from, let's say, see how far back I can take this. That's as far as it goes. Router on a stick is really, really simple. Assuming, let's take this guy. That's as big as it goes. Oh, I didn't want to do that. That's not cool, dude. I don't think I like that. Anywho, let's go back to, okay, there we go. So, well, these guys are trunk ports. They're configured already. What router on a stick does is it takes this guy, and what you would do is you would go under the interface command right here. Type in this interface FA0/1. Instead of hitting enter at that point, you would type in dot right there, and then the VLAN number. That's how I do it anyway. So VLAN 11.11. What you would do is you're creating a sub interface. So it would jump in from interface config-interface to config sub interface sub IF, and that's what you would get. And underneath there you would type in IP address, and then you would give it a IP address specific to that LAN. So 192.168.11.1, and then you would do the same thing. You would do a .30 for VLAN 30, and then you would type in IP address 192.168.1.30.1 for the default gateway, and then your subnet mask 255.255.255.0, and then you would tell it that now actually that's a couple steps too far ahead. In order to configure you'd have to go, once you have the sub interface set up, you have to tell it its encapsulation, because it'll squawk at you if you try to tell it put an IP address, I believe, but that's still up in the air. I'm not sure yet if that's true or not. But what you would do is you would go under the interface and you would say encap.1q. You could do ISL, which is Cisco proprietary, but I like .1q. .1q, and then the VLAN you're routing for, so like this case would be 11. So encapsulation .1q 11, and then you would go in the switch port, and then you would say trunk switch port mode trunk, or something trunk. Forget the command off the top of my head. It's been a little bit since I've actually configured this stuff, so it'll actually be a good refresher for me. So that's basically what you would how to set it up, and then once you have it set up, you're able to apply the IP address. This guy right here, .1 for the default gateway on the sub interface command. So then when you do a show IP interface brief, you'll have your normal, fast 0 or your two fast internets, your serial interfaces, and then you'll have your sub interfaces. And your sub interfaces will come in handy because then at that point you'll be able to see what you're routing for, and then at that point you'll be able to ping the other subnets from there. So that's how that works. So that's kind of a flyby overview of how it works. I'm not going to get into securing anything or anything like that. This is more of a, I wanted to cover this stuff right here. And now when it says the serial link between R1 and R2 is frame relay, what I think she means by that is that on the switch port itself, you're going to type in encapsulation frame relay, and then you're going to create what I would do. I don't know if this is how it's actually going to work. Is a sub interface like you would here. You type in all this plus dot whatever, so like dot 10, and then underneath that you would type in frame relay map interface delc, something to that effect. I forgot the exact command off the top of my head, but you're going to say interface, and then you're going to point it to this guy, and then you're going to point, so this one's going to get pointed this way, this guy's going to get pointed this way. So what ends up happening at that point is you have what they call a back-to-back frame relay, so you don't need a frame relay switch in the middle here routing your DLCs. So I hope she really goes into detail on how this stuff works, because I'm really familiar with frame relay and how it works. As a matter of fact, I end up troubleshooting it on a daily basis in my network. So if you don't get frame relay and you don't understand how it works, don't be afraid to hit me up, rriker82 at yahoo.com. Don't be afraid to hit me up or ask questions, and I'm actually going to post this on the discussion board, and I might even send out an email with a link to this particular my YouTube channel, and give it a kind of a basics video as to how stuff will work. And this is from me to the rest of the class, because this stuff can get confusing if you don't have a good explanation. Because frame relay took me probably half a dozen times of watching the video to really get an understanding of what it meant, the local significance of the DLC, and how it's a layer 2 address, and how stuff like that works. Because if you don't get it, you're going to struggle really bad. I know how CCNA 2 was, and people not getting how routing worked, and basic routing, static route pointed from here to here, and how the recursive lookup worked and stuff like that. If you don't get it, you're going to struggle. So like I said, if you have any questions, hit me up, rriker82 at yahoo.com. Don't be a stranger. I know this is a little long. I didn't plan it for it to be this way, but sometimes that's just how it works. But I'll probably do an upload tonight, so I can get it uploaded, and I'll send out an email so that everybody has at least a reference. And how far we want to take it is really up to you. I mean, if you guys are getting a good feel for it, then we'll go as far as you want to go. So I think that's about all I have to say for now. I mean, I could keep going based on what I see off the over here and in this section right here, but quite honestly, it's 11:30 at night. I'm tired. I have to go to work tomorrow morning. So I appreciate feedback, whether you leave it as a note or you dislike it or you like it. However you want to do it is fine with me. Just don't be a stranger. So I hope this has been informative for you, and I'd like to thank you for viewing.